Hey you guys, so in this video I'm going to do the second to last problem from your last homework assignment. So no one actually asked for an overview of this problem, but about the same number of students missed this problem as missed the last problem on the homework assignment, which was in the last video that I posted to play pause it. And I think that this one is actually much more difficult conceptually to understand. So I thought that I would give you a video here just in case it helps. And so let's get started on this problem. So this one's definitely kind of weird. We have one premise, and that premise is not A or not B. And the conclusion is, if not D, then not A and B. So right away we can see that something really weird is going on. We start with our premises only having the variables A and B. Somehow, by the time we get to the conclusion, we have another variable D and a conditional claim and a bunch of really weird stuff happening. So we need to figure out, how is this possible? How did this happen? And why is this still a valid argument? Okay, so let's solve the problem. Let's do the proof and see how this can possibly be the case. So again, our only premise is not A or not B. And we know that from line 2 that we're going to be able to derive the claim not A and B from this premise. So there's one rule of deduction, we've talked about it a lot before, that should allow us to move from not A or B to not A and B. So what is that rule? That's De Morgan's law. We have De Morgan's law here. Again, we've had a video on De Morgan's laws. This is one of his two laws, so we should be pretty familiar with this. Okay, so now we'll move on to our third line in our proof, and this is where things start to get weird. So in our third line, we have not A and B or D. And we've cited just the information in line 2, which only gives us not A and B. So again, line 2 says not A and B, and somehow we're supposed to be able to deduce not A and B or D from that. Okay, so why is this possible? What's going on here? First, let's go through our steps. So we've isolated our lines. Our next step is to simplify this as much as possible. Okay, so here we have the claim not A or B in our first line, and we have the exact same claim in the second line. So when we're simplifying this, let's just make this one single simple claim. So we could say, if we have P, then we can deduce P or, and let's say Q. So here we're saying that we have one claim, and from that claim we can deduce a disjunction, which has our first claim as one of its disjuncts, and a totally new claim as another disjunct. Okay, so that's the same essentially as saying if we have P, then we can assume P or Q. Why is this the case? Well, a disjunction only needs one of its disjuncts to be true for the whole disjunction claim to be true. So in order for P or Q to be true, we only need to know that either P or Q is true. Only one of them has to be true. If I tell you that it's Monday or it's Tuesday, that claim is true if it's true that it's Monday or if it's true that it's Tuesday. Only one of those things has to be true for the whole claim, it's Monday or it's Tuesday, to be true. So flipping this around, we can also say that if we know that one claim is true, such as it's Monday, then we know that a disjunction with that claim and anything else is also true. So if we know that it's true that it's Monday, then it's also true that it's Monday or it's Tuesday. It's also true that it's Monday or the earth is flat. It's also true that it's Monday or my name isn't Rebecca, right? So as long as we have one thing that's true, then we can make any disjunction that we want out of it. We can make it out of another claim that we know is true, like we could say it's Monday and it's sunny, or we could throw in a claim that doesn't make any sense, like it's Monday and the earth is flat. We can put anything else that we want in there as long as our first claim is true. So hopefully that makes sense why whenever you have one claim, you can create a disjunction with that claim and anything else you want. So there's only one rule that follows this pattern, the rule that lets you just create a disjunction as long as you're using one claim that you know is true. What is that rule? That rule is addition, and addition is a rule that lets us just add in really anything we want in our proof as long as it's a disjunction or as long as it's a disjunct in a disjunction claim with another claim that we know is true already. Okay, so this rule again is addition. Addition says if we know that one claim is true, then we know that any disjunction with that claim and any other claim is also true. Okay, so addition lets us say we knew that this is true, so we can just throw something else in there like D. And that's what we did. We just added D. Okay, so let's move on to the next line. Here we have if A and B, then D. And the line we're citing is line 3. So line 3 says not A and B or D. And somehow we can derive if A and B, then D from this. So what rule lets us take a disjunction in which the antecedent is false and turn it into a conditional claim? So first, let's back up. Sorry, I went too fast. So we need to go to our second step, which is to break this down into more simple terms. Okay, so we have A and B here. We have A and B here. It's the same disjunction on either side, so we can simplify that into one claim. Do we have to preserve our negation? Yes, because only in one line is it negated. In the other line, it's not negated. So here we would simplify this and say something like not P or Q. And to say that from not P or Q, we can deduce if P, then Q. Sorry, there's some glare there. I don't know how to fix that. Okay, so this is not P or Q and if P, then Q. What rule in your book tells us that from this type of disjunction with a negated antecedent, we can infer a conditional claim? That is implication. Okay, so we have implication tells us that if we have not P or Q, then we have if P, then Q. And that's one that we did in the videos, so we don't need to spend any more time on that here, but you can let me know if you have a question or just revisit that video. Okay, so our last line here, 5, says that from whatever we have in line 4, we can get if not D, then not A and B. And again, we've cited line 4, so now let's go up to line 4 and say, okay, we're inferring that from the claim if A and B, then D. Okay, so let's go ahead and simplify this again the same way that we had before. We said that we could simplify this claim as just a regular old conditional claim, if P, then Q. And here we have some new negation. That negation isn't present in our other line that we're looking at, so we have to preserve it. We have to make sure that we're including the negation in our simplified version of this. Okay, so here we have if P, then Q, then D was our antecedent, so D was in the place of Q here. This means that this line will read, if not Q, then not P. Okay, so our simplified version here that we want to compare to the book is that if we have if P, then Q, then we can deduce if not Q, then not P. So what rule in our book tells us that we can make that deduction? That's contraposition. Okay, so contraposition tells us that from here we can get to if not D, then not A or B. And now we actually have our conclusion, so we can discharge that, and we're done with our proof. So now we've seen how we could start with a claim like not A or not B, and end up with a claim like if not D, then not A and B. Again, I think that conceptually this is difficult to wrap your head around. Even after an explanation, that can be difficult to understand. I know that I still struggle with it sometimes, keeping this straight. So I think that's what makes this so difficult, is that conceptually it's hard to see why you can just introduce this claim here like D and then all of a sudden turn it into a conditional claim. But we know from our truth tables and from the rules of logical equivalence that this is actually a valid deduction and this is a valid argument. So this proof shows us a valid argument. Okay, I hope that makes a little bit more sense. Please, as always, let me know if you have questions.